video, the learning goal is to utilize a graphing calculator to adjust the windows and identify key features of a function. Now this is difficult to do at home when you don't have a graphing calculator. So this morning I've spent quite a bit of time looking into options you can use. This is a TI-89 online simulator. What you use in class is an TI-84 Plus. So the functions you can do on the calculator in class are relatively the same that you can do within this. And you're wondering where to find this? Well, this is the address to find it. It is free. I also already took this link and I posted it this morning on Teams, so look for that. Now, another option is to look for this graphic that I'm going to pull up right now. And I just learned about this today. If you go into, and I cannot share with you if it works for non-Apple phones, but if you have an Apple phone and you go to the App Store and type in Calc, C-A-L-C, type in Calc, leave a space, and type in the numbers 84, you're going to see this as an option. This is free, and so I downloaded this, and I'm going to show you how much of the same that we do on our calculators in class can also be used on this app. Now, when you're in class, you're going to need to use the calculators I provide you. And the main reason for that is that in any of your district exams, for those that are going to be going into accelerated calculus, you have to always be able to use the calculator, the TI-84. You are not allowed to use a calculator or an app on your phone. So, but at home, this allows you the opportunity to continue to do work that you don't get done in class. So I took this, downloaded it to my phone. Later on, I will show you again how we can use the simulator in a different video. Let's look here. So in this particular problem, number 3, I'm provided with a function and I'm told to adjust the windows. So let's do that. First, I've already cleared this. I'm going to go up to y equals, typing in x squared plus 5x plus 6. And now when I hit window, I want to adjust the window to go x is between -5 to 5. -5 to 5, skipping the x scale, and now doing the same for the y's, -5 to 10, skipping the y scale. When I'm done, I'm going to graph this function, and then I'm going to draw a picture of what I see. So I've drawn a rough sketch of what this looks like, and now I want to identify the y-intercepts and the zeros. I can see there's two. Okay, so let's by finding the y-intercept. The first time I hit trace, I can see the y-intercept is 0, 6. Remember, when we identify the y-intercept, x will always be a 0. Okay, let's identify each one of these zeros. So I'm going to go second trace, then go down to 0. I need to go somewhere to the left of this. 1, 2, 3, somewhere to the left of -3. Let's try -4. Now somewhere to the right, but before I actually come to the second 0. So let's see, 1, 2, somewhere between -2 and -3. And now I have these two temporary vertical lines. Pressing enter one more time, I have one of the zeros. Let's figure out the next one. Again, I'm going to go with -2.5 to the left and now to the right. Let's try -1, pressing enter, I get -2, 0. How can you do this at home if you don't have a... So I've downloaded this free app, says Calc 84, I'm clicking on it. I'm going to y equals, I'm plugging in right away the function I'm provided. I'm going up to Windows and I'm switching what I have. So I'm going to clear this. Let's see if I can clear it. Typing in -5, enter. Again, let's clear this, typing in 5. All right, going on down to y minimum, I'm clearing it and going to -5. And y maximum, I'm clearing it, going to 10. I'm learning this with you as we go. Okay, so my first thing was the y-intercept. I'm going to come up here and click and see if we can figure it out. Let's check. We're learning this together. So I'm going to go to roots, because if you don't know this from freshman year, the words zeros, roots, and x-intercepts all describe the same thing. Again, please write that down. Roots, zeros, and x-intercepts all describe the same thing. They all describe where does our function cross the x-axis. So I'm going to hit root, and I can see automatically the two roots appear. Perfect. -3 and -2. Wonderful. Now I want to know, what is the y-intercept? Remember, when we find the y-intercept, x is always 0. Again, I am learning this at the same time you are. So let's go and figure out, let's see here, intersect, nope, let's see, trace, there we go. So let's trace to find out, we need to do an exact here, so let's figure this out. I'm going to press pause, figure out how to find the y-intercept using this new technology. Found it. Okay, so let me come back here. This is what we have. We're going to move this down so you can see everything. Again, you've hopefully taken time to download this free app. I'm going to go to calculate, and again, I know that when I'm trying to find the y-intercept, x is always going to be 0. I'm pressing return, and there's my answer, 0, 6. Let's go on to number 4. Remember, whenever you start a new problem, we're going to go second plus 7, 1, 2 on our graphing calculator. And as a reminder, in class, you'll be using the graphing calculators at all times. Whenever it says standard viewing window, that means after we do second plus 7, 1, 2, that's what we're provided, negative 10 to 10, negative 10 to 10 for both x and y. So we're going to go ahead and we're going to graph a function. All right, we're able to see the function we're provided in number 4. I'm going up to y equals, how do we plug this in? 3 subtract. Now, I need absolute value. You may want to write this down on the graphing calculator. We got to get to the app that puts in absolute value. So I'm going to go to math, NUM for number, and it's the very first one. Math again, I'm going to go back so you can see this. It's math, scrolling across to NUM and pressing enter. Now, inside is x plus 2. And if you remember from freshman year, whenever we have absolute value, we have these V shapes. The V can go up or the V can be opening down. Let's see what this looks like. Within the standard window, we want to draw a picture. Okay, so just a rough estimate of what this looks like. Okay, it's looking something like this. Got it. And now we want to identify the y-intercepts and the zeros. Now, what are other words for zeros? Roots, zeros. So I'm going to start by going up here to trace, hitting trace one time, and I have 0, 1. Simple enough. Now x-intercepts. Oh, it looks like it has a nice precise intersection. 1, 2, 3, 4, 5. Let's check here. I'm going to go to the 0, somewhere to the left of negative 5, somewhere to the right of negative 5. So now I have these temporary vertical lines in between. So negative 5, 0 is in fact one of the zeros. Now over here, we're going to go, it looks like it's maybe 1, 0. Second trace, 0. Let's go negative 1 and positive 3. Something to the left and right of our 0. Pressing enter, and I have 1, 0. Can we do this on the other graphing device? Well, let's try to do it together. You can see to start with, I came back to this app. I went to y equals, and we still have the previous equation in there. I'm going to clear it. Now, how do I type this in? 3 subtract. Okay, I need the absolute value. Remember, here I went math. Then I went to number and chose absolute value. Let's see if the same works over here. Math, okay, number, absolute value, there we have it, x plus 2. Now our window, remember, we needed to go, as it says in standard viewing window, from negative 10 to positive 10, making sure to clear it out each time. Negative 10, oh, I'm forgetting to clear, negative 10 to positive 10 and graphing. Okay, so the first thing we're going to do is let's figure out if our x-intercepts are the same and I've done this correctly. I came down here as a reminder, zeros, roots, and x-intercepts all are terms that mean the same thing. It means where does our function cross the x-axis. I'm going to hit root right down here. I'm going to hit root, and we can see right away I have the same answers, negative 5 and positive 1. Now what about that x-intercept? If I go to calculate and I type in 0, whenever x is 0, I press enter. I always get a y-intercept. In this case, it is 0, 1. And again, we have the same answer. If you've not done so, please attempt to download this free app. Hopefully you've taken time to go ahead and to download that app to your calculator. So the next thing we're going to do is we are going to talk about absolute and global maximum and relative and local maximum. So these are terms you should have heard freshman year. Maybe you forgot them, maybe you weren't exposed to them. You're going to want to write this down in your notes if you don't know this. Absolute and global maximum mean the same thing. Absolute and global mean the same thing. This means you have one high point, can't be shared with any other point. If there's one point that stands out as the absolute highest, we can either call it an absolute max or a global max. It kind of depends who's the author of the mathematics text we're looking at. If there's one and only one point that stands out as the absolute lowest, we call it an absolute minimum or a global minimum. Now, if there's other points that I refer to as high points, just not the highest, or low points, just not the lowest, we call those relatives max and relatives mins. Let's look at a couple. We have three graphs that I've drawn, definitely not very pretty, but let's first start by looking is there one point that stands out as the highest in my first graph? Well, these arrows insinuate that as the graph moves to the right, it's going to continue to go up. And as the graph moves to the left, it's also going to continue to go up. So it goes diagonal as it goes to the right and diagonal upward also as it goes to the left. What do those arrows mean? It means it never stops going up as it goes to the left or the right. And since it never stops, I can't say that there's a high point. This has no high point. There's not one and only one point that stands out as the highest. And for that reason, there is no, whether you use the word absolute or use the word global, it's up to you. There's no absolute. There's no maximum, absolute, global, or, there's no absolute maximum or global maximum because there's not one point that's the highest. Now, what about, is there a point that's the lowest? There is one point and only one point that stands out as the lowest. So we'd refer to this, and again, you can use the word absolute or you can use the word global. You don't have to use both. I'm just putting them both there so you get accustomed to them. And this is a minimum because it's one and only one point that stands out as the highest. Now, there's other points that are high points or low points that are just not the highest or the lowest. Here's an example. Here's a low point. It's the bottom of a valley. It's just not the lowest point. What do we call that? We can either call it a relative minimum or a local minimum. They mean the same thing. I'm going to abbreviate. There's, well, relative or local minimum. Either one of these terms would be just fine. Here's another high point. This is a high point. It's just not the highest point. So again, we're going to call this a relative or a local maximum. The big confusion with this problem is why is there no absolute and global maximum? Why? Because not one point stands out as the highest. You can't say this is the highest, you can't say this is the highest because it continues to go up. So it's going up to infinity as it goes to the left and going up to the infinity as it goes to the right. Let's move on to our second graph. So in our second graph, this arrow insinuates that as it moves to the left, it continues to go up and it will never stop going up. And as it moves to the right, it will continue to go down and it will never stop going down. So for this problem, there is no absolute or global maximum. There is no absolute or global minimum. So there's no absolute or global max or min. Now, why is that? Because the arrow on the left shows that it's going up and it's never going to stop. The arrow means it keeps going up to infinity as it goes to the left and it keeps going down to infinity as it moves to the right. Now, relative and local maximums, this is still a low point, it's just not the lowest. So again, we can call this the relative or local minimum. And this is a high point, it's just not the highest. So we call it a relative or local maximum. Let's look over at graph number 3. Let's start with the absolutes. So is there an absolute high point? The highest point there is. This is the absolute or global max. So this is the absolute max, or you may want to call it the global max. Interchangeable terms. Now, is there an absolute or global minimum? Is there one point and only one point that stands out the lowest? There's not. Why? Because this arrow means it keeps going down. So as you go to the left, it keeps going down and it never stops. That means if it never stops, I can't pinpoint one and only one point that's the lowest. So there is no absolute minimum. Now, is there relative or local, depending on which term you prefer to use, maximums or min? Sure. This is a high point. It's just not the highest. So we could call this relative or local maximum. And again, this is a low point. It's just not the lowest. So we can call this a local minimum. Let's graph this now, coming up to y equals. I will show you a common mistake that even I make if I'm not continuing to look up here. So I'm going to go x, I'm going to raise it to the third, and watch what I will do. If I don't look back up here and I go plus 3x squared, you can see that it's all being translated here into the exponent position. I'm going to go back here and remind myself that after, let me just clear this actually, after I do x to the third, I need to use the arrow to go back down. Plus 3x squared, subtract 6x, subtract 8. Okay, ready? Here we go. So we want to identify these terms like absolute and global max and min and relative or local max and min. Now, when I look at this, I just feel like I'm not getting a great picture of this. In terms of the x's, everything is great, but I'm not seeing high enough or low enough. So I'm going to go to Windows and I'm going to adjust the high and low, which would be the y values. Let's break this out into, I don't know, let's go down to maybe 25 and positive 25. Minimum is always your negative, the lowest of the 2 points, and y maximum is the highest. Now, if 25 isn't high enough or low enough, I'll just change it. Okay, now I have a picture here, and I'm just going to give myself a very simple graph of what this looks like. Very, very simple. Comes up, comes back down, and goes up. And even though we don't see arrows here, it insinuates that it continues to go down and it continues to go up. So for this problem, there is no absolute or global maximum because this arrow means it keeps going up and it never stops. So no absolute maximum. And again, same thing here. There is no absolute minimum. You may use the word global maximum or global minimum. In either case, there is none. Now, why? You have to be able to explain the why. The why is because this arrow insinuates that as I move to the right, it'll keep going up and it'll never stop. In order for us to have an absolute maximum, there has to be one point that I can show you. Go to this point on the graph. Look, it's the absolute highest. There's not one point. The arrow says it keeps going up, it never stops. Same thing for the absolute minimum. Is there a relative or local maximum? Sure. This is going to be the relative max because it's a high point. Sometimes students will say like it's the top of a hill. This is the bottom of a valley, so it's a relative minimum. Now we want to find those points and we're going to round to the nearest hundredth. How can we do that? So I'm taking the graphing calculator. I'm going to start with this high point. So it's a maximum. It's called a relative maximum or a maximum. Second trace, go to maximum, and then use these arrows to go up to the top of the hill. And now we're going to follow the directions. Go to the left and press enter. So I go anywhere to the left, press enter. Go back to the top. Now go to the right. Go anywhere to the right and press enter. And now go to the very top and press enter. And we're going to round this. Here you can see I've rounded to the nearest hundredth. Now let's find this minimum. Second trace, minimum. And I'm going to start at the very bottom of the valley before I follow instructions. Go to the left. Got it. Go to the left. Now go back, go to the right. Okay, so I go anywhere to the right. Got it. Now go to exactly where it's the lowest, press enter, and we can write down this ordered pair, running to the nearest hundredth. Is it possible to do this using my cell phone and the app? I'm going to check it out with you. I have no idea. We're going to learn this together. Start by plugging in and see what we can do here. So I want to plug in this formula. Okay, hold on one second. So I have x to the third. So x caret 3, bring it back down, plus 3x squared, subtract 6x, subtract 8. And I already reminded myself that I need to go down to Windows, clearing it out and try negative 25, clearing out and trying positive 25. Okay, this looks pretty good. Now remember, we want to identify the relative max and the relative min. So you're doing this with me at the same time. Hopefully you've downloaded this and you can press pause. I'm now going to take my calculator, put it into a vision where you guys can see all of this. And you want to take notes on this if you're using your calculator. I'm going to go to where it says extrema. So I'm going to go to the extremes here, the high and low. I press enter and we have the exact points. Negative 2.73, 10.39, and down here 0.73 and negative 10.39. Exact same things. This is your calculator. Again, this is free to Number 6 and number 7, I would like you to practice on your own here, pressing pause. I'm going to do one using a graphing calculator, the other is going to be using the calculator that's on my phone. So second plus 7, 1, 2, we're going to speed it up here for you. Second plus 7, 1, 2, going to y equals and plugging this in. So I have x to the third, bringing it back down, plus 2x squared, subtract 8x, and plus 10. Now I need to adjust the window to make sure I can see everything. Let's take a look at this. Okay, I can't see what's happening up here. I'm going to go to Windows, and remember, when we go up or down, that's our Y value. So I'm going to pop this up to like 30 and see if I can see enough. I may need to adjust it even further. Okay, great. I have a good view of what this looks like. You don't have to do this, but for me, it helps just to identify what does this look like. It looks something like this. Okay, so again, this arrow means there's going to be no absolute maximum, and there's going to be no absolute minimum and no absolute maximum. Why is that? Because this insinuates that it continues to go up as it moves to the right, it's never going to stop, and it continues to go down as it moves to the left, it's never going to stop. So no absolute or global minimum, no absolute or global maximum. These points are known as our relative or local max and mins. Second trace, going to go to, let's start off with our maximum, and I'm going to go up to the very top and follow directions. So to the left, anywhere to the left, pressing enter, to the right, anywhere to the right, going up to the very top, and now I'm going to go ahead now and I'm going to do the relative or local minimum. So second trace, going down to minimum, and first I'm going to start at the very lowest point, right there, going to the left somewhere, pressing enter, coming back, going to the right somewhere, pressing enter, and now guessing and writing this down. It's a great opportunity to talk about rounding to the nearest hundredth. Hundredth is 2 places to the right of the decimal. So right here I have 1.09, so I'm looking at the 9 and then I'm peeking behind it. Because the number behind it is 5 or greater there, I need to bump up 9. So 9 bumps up to 10, and for that reason, this will be, when I round to the nearest tenth, this is going to be the order pair that represents our local minimum. Can we do that using a graphing calculator? Well, we could try, but we're going to do this entire problem using a graphing calculator. So when you have our previous problem, I got to figure out what to do here. So let's see, we're going to continue. It looks like my calculator doesn't have a lot of space. Let's bring this down really quick. Give me 1 second. Okay. Give me 1 second here to clear this off. Okay, it's back with me. So I'm going to y equals, and I'm going to clear this off and plug in what I have, -8, x, oh goodness sakes, let's try it again. Gotta get to this side, -8x to the third, taking my time, going back down, plus 8x squared, great, subtract x plus 10. Feel free to press pause, plug this into your own phone to make sure it works. I'm going to graph it and then adjust the windows. Oh, okay. So I can see that pretty well. So if I'm going to draw a picture of this, it looks something like this. It's coming up like this. There's just a little spike down and up again. So again, this arrow means there is no absolute maximum and there's no absolute minimum, also known as a global maximum or a global minimum. Why? Because as it moves to the left, it continues to go up, it never stops, so there will not be one and only one point that's the highest or only one point that's the lowest. You do need to be prepared to explain that. These points would be referred to as the high and the low. So when I hit extreme, I can see those points. Now I may need to zoom in again a little bit more with my fingers. That's awesome. And we can see these exact points. So this would be known as our relative or local minimum and our relative or local maximum. Okay, we are going to now using the graphing calculator. I'm going to start again by second plus 7, 1, 2. And I'm going to plug in a new equation. So we have x to the third plus 3x squared, subtract 6x, and subtract 8. And in this problem, it just wants us to fill in what are the output values when x is 16.1, 16.2, 16.3. Here's the key for you to realize that I want to show you, it's going to show that there is a conflict with the calculator. When you simply go, hey, I want to know the value, and you type in 16.1, It's going to say, I can't tell you that, 16.1. I can't tell you that, and here's the reason why. When we go to Windows, we've set it so that the most it will go out to for an input value is 10. Yet I'm trying to get output values that match up with input values that are far beyond 10. So I need to make sure to adjust my X maximum to go past these three. So let's come out here and do 18, for instance. Now we may also have to adjust our Y's. Let's see what happens now. Second trace value, I can type in 16.1, and here's my answer. So this is what I would write down. It says to round to the nearest tenth. I would write down 4,846.3. And now I'm going to go to a value of 16.2, 4,933.6, and back to value lastly, 16.3. And I have an answer of 5,022.0. So the whole idea here is that we need to first adjust the window before we use the second calculate value. Ensure that it's within the parameters that we have set out. Okay, let's look at right now at number 9. Let's jump and use this calculator. So let's see if I can do my y equals. Give me a second here. And I'm going to adjust this for what we have. So let me come back here. And so my y equals is, I need a parenthesis, x plus 2, it's very important you do use parentheses, plus 2, and parenthesis, divided by x minus 4. And I gotta look back up. Okay, all of that looks good. I'm gonna return, done, and I wanna bring this back so we can see this. Okay. So this is what we have. Now what we need to recognize is that, remember, in the denominator you can never have 0 as an answer. So some of you can just do the mental math. Others are going to take the denominator. Anytime we have a fraction as a function, we're going to set the denominator equal to 0 and we're going to isolate the variable x. So I'm going to add 4 to the other side. So x is by itself and 0 plus 4 is 4. What does this tell me? It tells me x can never equal 4. Notice that I could actually draw a line here at x equals 4. X can never equal 4 because if x equals 4, I'd have a 0 in the denominator, and that's breaking a math rule. So for this problem, let's just draw a little small sketch of this. Here's at 4. I'm going to do a little dot here. I know x can never equal 4, and then I'm going to mimic what I see here. So it looks something like this. Let's see here. It looks something like it cuts over right about here. Something like that, and something like this. Okay, let's answer the questions. Draw a picture that models the function, and now answer these three. So let's figure out when x is 3. So I'm going to calculate, typing in 3, and pressing enter. So when x is 3, the output is -5. Now I'm going to skip ahead to 5. When x is 5, pressing enter, the output is 7. Now we know we cannot input in 4. If we put in 4, we get a 0 on the bottom. We call this undefined, but let's see what it says on our calculator. If I come up here and I type in 4, I'm going to guess it's going to say error, or it'll just be blank. Let's check. It says NaN. Well, the answer is it's not possible. That's really the mathematical term is undefined. We use the word undefined to describe when we cannot actually calculate it at a specific value, because by calculating it, we'd have 0 on the bottom, again, breaking the math rule. Let's jump on to our last problem, number 10. Back to the graphing calculator, 2 plus 7, 1, 2. Going to y equals and typing in x squared, subtract 5x, subtract 3. And I want to calculate the zeros and round them to the nearest tenth. I can see 2 zeros. I want precise answers. Second trace 0. I want to go somewhere to the left of this, -2. Somewhere to the right, let's go +2. Okay, it is in between. Pressing enter, one answer is -0.5. -0.5 if I'm rounding to the nearest tenth. Let's do the next one. Second trace 0. Maybe over here is about 5, maybe about 8. So it's in between 5 and 8. Pressing enter, the other is 5.5 and 0. 5.5 if I round it to the nearest tenth. Jump down to 13 and 14, doing 11 and 12 in class with you. I'm given 2 points, x1, y1, x2, and y2, and I want to write an equation that models this data. So I need both a slope and I need a y-intercept. Now you need to memorize this equation, y2 minus y1 over x of 2, x minus x of 1. Remember, your y's always go up front. Now, I always suggest to put parentheses and then we'll plug in the numbers. Since this is the first point listed, I have it as x sub 1, y sub 1. Second point is x sub 2, y sub 2. So I'm taking 7, subtract 1. And then taking 4, subtract a negative 4. 7 minus 1 is 6. 2 negatives make a positive, and 4 plus 4 is 8. Now, if you don't reduce this to 3 over 4, that's okay. I'm okay with you simply leaving it as 6/8 at this point. Y equals 6/8 x plus b. Next, you choose one of these 2 points. There's no wrong answers. I'm going to choose the one that doesn't have any negatives. This is the x, and this is the y. So y equals 6 over 8 times 4 plus b. Notice that underneath the 4 is a 1. So 6 times 4 is 24. Oh, let's put a 28. And 8 times 1 is 8. 24 divided by 8 is 3. And now to isolate the b, I move 3 to the other side to get an answer of 4. There's my answer, and here's my answer. So y equals 6/8 x plus 4. Also, you could write y equals 3/4 x plus 4. That's just a reduced form. Let's look at number 14. I would love for you to press pause, do 14, and then come back to see if you get the same answer that I do. So I'm going to do a little less work here for you as I go through this. Do you have to show all your work? Absolutely. So negative 9 is my y2, positive 3 is my y1, 6 is my x2, negative 12 is my x1. Negative 9 and negative 3 is negative 12. 2 negatives make a positive. If you are somebody who struggles with integer operations, like you just know this, like, Miss Bradley, I understand what you're explaining, but I'm just not good with adding and subtracting integers or multiplying. Please individually come talk to me, and I'll set you up with a program just very simple, where we do 10 minutes of practice at home every night, in which you will get better at this. This will prepare you that when you go to college and you take those placement exams, you are ready. Okay, if you want to reduce this, awesome, but if you don't, you can still get the right answer. Choose either one of these. It doesn't matter which one. No wrong answer. I'm going to do the first one. This is my x, this is my y. So 3 is my y, and in for x is negative 12. And I'm going to put a 1 on the bottom. Okay, so negative 12 times negative 12 is a positive 144. And I'm going to grab a calculator really quick, and I'm going to take 144 and divide it by 18, and you can see we get an answer of 8. So this is 3 equals 8 plus b. 3 minus 8 is negative 5. So I have my b. I had my slope, and if you never reduce it, you'd have negative 12 over 18x minus 5. Now, you could reduce this. So you can ask yourself, how many times does 6 go into 12? 6 goes in twice. How many times does 6 go into 18? 3 times. This would get you the exact same linear line. Make sure you've taken notes through everything and be prepared to show them to me on Tuesday.